Good day, this is Hassan from Cask Software, and this is a screencast for the getting started session for Spudpen. Well, basically you have to go to the address of app.casksoftware.com/login, or if you even do not put /login, it automatically will direct you to this login page, and within the user credentials that we have provided to you, you can log in into the system. And once you put your email address and the password, the credentials actually that we provide to you, you can also click on the remember me just to avoid every time put your username or password. You can sign in. Once you sign in, Alright, so once you have signed in, then you will see different applications, Spudpen, KSON, and GeoVision. There will be more applications soon on this dashboard page. So since this screencast is about Spudpen, we open Spudpen here. So you can click here on the Open Spudpen. So once you open it, you will see a history or records, previous records of the analysis that you have done within the time that it has been created, and also the user. You can also delete that if you want, or you can always go back to that previous analysis and start editing and redo the analysis. But for starting an analysis from scratch, you can create LPA. So go ahead and click on the Create LPA button here. So once you have done it, then you will see that there are a couple of tabs on the graphical user interface that you can start putting data in it. And basically there are two ways for Spudpen that you can generate data and or to do an analysis basically. One is the wizard mode, or basically there are some menus with the explanation what parameter you need to input. So basically this is the create new here, or you can just click on the direct import, basically where this is for the pro or advanced user who have read the user manual of Spudpen, and they can make a kind of like a input file for the Spudpen, and then directly they can upload it over here. Since this tutorial is just for the users who want to just get started and to learn about how to do a simple analysis in Spudpen and doing a lake penetration analysis, so we do not cover that. Anyway, I encourage any users to read this user manual of Spudpen, at least up to page of 40. You see that there is, it's around like 300 pages. So I advise every user to just read until page 40 to understand exactly how the bearing capacity and lake penetration analysis is being done. This software, Spudpen, is based on ISO standard, ISO 19905, and it's basically compliant with the one of the latest, actually with the latest version, which is 2023, and which is also with the agreement of a lot of marine warranty surveyors and also a lot of designers. So on the first tab here, you can start inputting the data, so it's one by one. So project title can be test project, and then the client can be client A, for example, and then the project location can be, for example, North Sea, and location ID can be the exact location that's a CPT, for example, test have been done, or SPT or borehole have been done there. Or if there is a specific location, you can just put it there. Let's say, for example, here I just put W14, which is a code name for a location. There is also a description here that you can use it, but it's not mandatory. As you can see that once I had up to this point, then a kind of like an equivalent input file can be also be made here. If you're absolutely beginner in doing the analysis, you can just discard this, because everything on the left column has been designed in a way that to catch the errors that you have inputted in the input data. So if you would like to know how to make the input files, yes, you can just check that, for example, which data here that you change and what kind of influence that it has on the right side, but it's not mandatory. So here I am complete, and also description, I don't want to put any description here, so then I can go ahead and push next. So next tab is actually the soil data. So here we are going to make like a layering of the soil. So it's actually composed of a couple of parameters. The first column is the top elevation, so it's actually, it indicates that where the soil starts basically. So we always start from 0, and it should be from 0 because that's where the sea bed level starts. The next parameter is gamma prime, or submerged bulk density, submerged density of the soil. Normally, when we are talking about the saturated soil, we are talking about the submerged bulk density of around like 17, 16 at the loosest state, until 22, which is really dense state. So if you minus basically the water specific density, then specific unit weight actually, then you can generate the submerged density. So so we are talking about something like, for example, 8, 9 most of the time, or 8 to 9. It can be also float number like this for the soil. So for these soils, basically in geotechnical engineering, we divide it into two broad categories. Either they are clay, which they have undrained shear strength, or if we have friction angle. If we have clay, then you have to input the SU, or undrained shear strength, at the top of the layer, and also SU, undrained shear strength, at the bottom of the layer in the units of kilopascal. Let's say, for example, here we have a soil, a clay layer, which starts at the undrained shear strength of 40 at the top, and then at the end of the layer, which, for example, let's say at 5 meter, we have the undrained shear strength of 100. Please bear in mind that this SU profile should be always only uniform. So for example, you can make like a top to toe the same number, like 40-40 or 100-100, or it can be increasingly linearly increasing with the depth, basically. For example, just like with the like the condition here we have. For example, we have here 40, and then at the bottom we have 100. Since this is clay, so we just put you can just leave it empty, or you can just put 0 for the friction angle, and then you go ahead and press add layer to go for the next layer. So the next layer starts at 5 meter, and also the gamma prime, for example, let's say I just put it 9.1, and this is a sand layer, imagine. And then, so since this is a sand layer, then you can just leave SU values empty, or you can just put 0, and then the friction angle can be like, let's say 30. And then you can go ahead and add final layer. Let's say that we have also another layer starting at 10, and also at a submerged density of 9 kilonewton per cubic meter. And also this is again a clay, so it has the SU, a uniform SU of 200 kPa and also 200 kPa, and the friction angle must be 0. And also end of boundary, where, for example, we know that this is the end of the soil profile that we have here. I just put it like 20 meters. And then, if you would like to do like a lower band or upper band analysis, you can just repeat this process. And basically you have to do 3 separate analyses. Imagine that these 40, 100, and 200 and 200 here are just like your best estimate profile. then if you have like a lot of that data, you can already do like your analysis. Imagine that for example, you have a couple of CPTs, and then you see that if this is Z, the depth, and this is QC, or let's say you have SU and you have a couple of data points here, and then based on the analysis that you have done, you determine a kind of like a lower bound, you determine a best estimate, and also you determine upper bound. So then you can, for each analysis, if you do like a lower band analysis, you can you can select the lower band profile, this line, which for example can be on 20, the best estimate, let's say for example it's at 40, and also upper estimate is like 80, for example, kPa. So this is basically the way that you do the analysis for the lower band and best estimate, and basically you have to repeat it. Imagine that you have to do the analysis in the lower bound analysis, and in the best estimate, and also in the upper bound. Basically you have to do one analysis for lower bound, one analysis for best estimate, and one analysis for upper bound. So let's go ahead and we start next. Here we go into the tab of Spudpen, basically where we enter the data for the jackup and also for the Spudcan. So as you can see here, we have Spudcan diameter and also Spudcan offset. So let me explain a bit what are these parameters. Imagine that we have a Spudcan geometry like this. So basically, Spudcan diameter is the diameter from here to here, and also offset is the distance from the tip of the Spudcan, let's say here. So this Spudcan shape starts at here, at this point. So at this point, because we have like a pointy shape, then the Spudcan diameter is 0, because basically at the cone, at the tip of the cone, we have 0 diameter, and also the offset from tip is 0, because it's exactly at the tip of this Spudcan. So then we just enter 0 and 0, and we add point. For the next point, we go to this point. Imagine that here, this diameter is around 2 meters, and also the distance from here to here is around 1 meter. Then what you do is that here you input the diameter and also 1 meter Spudcan offset. Then you go and add another point. And imagine then we reach to this point. This diameter is around 14 meter, and also the distance from the tip from here basically to here is around 2 meters. So 14 and 2 is the next entry we have to add. And basically you just add this information until you have a growing diameter in this Spudpen, and you just stop there. So this means that you don't need to enter this one, or you need to enter this one. That's enough. So you can give also a name to your Spudcan, which can be sea diver. It's just a dummy name. And then you can also indicate the amount of the preloading in meganewton. Let's say this one has a preloading value of 100 meganewton. And here you also indicate the Spudcan volume in cubic meter. Spudcan volume in cubic meter is basically the total volume of the Spudcan in 3D until here. Imagine in this case, for example, we have 850 cubic meter, and also you have to enter still water reaction. And the still water reaction is that basically the amount of the reaction per leg that normally in the calm sea state without any wind load or any other load every leg of a Jacob platform is experiencing. If you don't have that data, you can just put a kind of like a value of half or 20% of this preload. For example, in this case, I just put 25. But please bear in mind that for the moment, this input does not have any influence on the results. This is just because later on we would like to add the fixity curves for the analysis, which we will see probably next year. So then let's go ahead and press next. Yeah, and these are the last step, which are the factors. Well, I just recommend that for the most part you don't need to change any of these capacity these factors. These factors influence the bearing capacity that are being calculated. If you want to know a bit more, you can just read the manual, and again, up to page 40, all of these factors have been already explained. And this is the backfill above Spudpen. Basically, there are three options: no backfill, partial backfill, and full backfill. So let's show you that what is this. Basically, you know, when a Spudpen is being penetrated into the ground space, basically it just goes downward into. So you see that it leaves a kind of like a cavity above the Spudpen, and sometimes this cavity remains open, but if, for example, you are doing the leg penetration analysis for the long time, then due to the action of the currents and waves, this can be flattened out. So if you want to be really conservative in your analysis, you can always go ahead and select full backfill, which means that it just consider that there is a flat ground, flat seabed above the Spudpen, and which means that there is a lot of soil load depending on the penetration on top of the Spudpen. So that's why it's conservative. So once you have finished with that, then you can just hit the calculate button, and it will show you a plot of the penetration versus depth and also a preload value here. So I just press it again, and then it also comes with a full detailed output file and also a PDF report. So you can see that this is the amount of the penetration on the vertical axis, and also on the horizontal axis we have the net resistance basically. So we have defined our preload at 100, so this is the amount of the preload, and this is the amount of the resistance. So where these two lines are cutting each other, so that's the expected penetration. So here in this case we should expect a penetration at around just above 5 meters below seabed. And also an indication of the Spudpen geometry is being shown here that we have inputted here. And also we use a kind of like a color coding for soil. So the first 5 meters, if you remember, it was clay, so we just shaded with the blue, light blue color. Also from 5 to 10 we said that it's going to be sand, so it's yellow. And also again from 10 meters until 20 meters, which is the end of the boundary, it's clay, so it's again blue. And here you have a lot of buttons that you can see. You can download basically the input file, which is just based on your inputs that you have entered on the different tabs here. So let's go ahead, we can download it, push on it. So you can also download the output file. You can output a kind of like an Excel file of exactly the same curve. You can also download the PDF file. You can also download the data in CSV, which is exactly the same data as Excel. So here you can just, let's just open the files that we have downloaded. This is the input file. It always starts with a number and dot capital I01. This is our input file. So this is our input file. So as you can see, this is you know, the test project client A North Sea W14, which was our location, and a lot of more data here. This is output file. As you can see here, it shows just a lot of detail about the information. And also this is the PDF 2-page PDF file, and so on. And if you like, you can, for example, go ahead and start a new analysis, and this time you can just do in the import. So the same input file that we have downloaded from the previous analysis, we can just drag and drop it onto here until it's being uploaded. You can just give it a kind of like a title project. Here I can just give it like a test project, and you can also process upload if you like. So this is another way of doing the analysis if you have the input file already. So once the analysis have been done, then you can see a kind of like the same output here, as you can see. So this is exactly the same output because the input file was the same. Should you have any further questions, or if there are some points which needs to be clarified, you can always send us an email, and we can also assist you in doing the analysis from A to Z, basically from the beginning to the end. Thank you. Bye.